year 2002 by Christian Schulz and Wolfgang Blessing. And in the meantime, we were growing over the years, and in the meantime, we have more than 100 employees all over the world. And in Germany, we have 2 locations. One is located in the north of Germany, close to the Danish border, and one is located in the south of Germany, where I'm coming from, and this is located in the Black Forest, near the Swiss border and near the French border. So what we have is we have innovative products, and all the products you can see in our catalog and on our website are really developed by ourselves. So we have a big development department, and we also have our own manufacturing department. So both development and manufacturing is done by ourselves. Next thing what we can offer to our customers is the calibration of the dew point sensors. So the calibration test equipment is very difficult. Dew point calibration is not an easy thing like temperature or pressure calibration. There are much more efforts to do. And for our flow meters, we also offer the calibration of flow meters. In the past year, we were growing very quickly, and in the meantime, we have a lot of CS Instruments subsidiaries all over the world. For example, France, Italy, Netherlands, Sweden, Austria, Switzerland, Spain, China, and so on. And in all other countries, we are working with dealers. So this is, for example, countries like Egypt, Argentina, Brazil, Czech Republic, we cooperate with JSP, Israel, Kazakhstan, and so on. So you can find CS Instruments as a manufacturer all over the world. What kind of product range do we offer? So on the one hand, we have, let's say, more or less measuring technology for compressed air and gases. And of course, we also provide solutions for reliable monitoring system. So, on the one hand, we have the chart recorders and data loggers, which could be used not only with our own sensors, they could be used with all other sensors as well. So they have the open 10 volt input, they have 40 20 milliamp input. They can use with RTDs, PT100 or PT1000, for example. The chart recorders are not only for CS Instrument sensors. Then we have the dew point measurement. We offer the flow measurement. And one big topic in the compressed air is the compressed air quality. So most of the factories are interested in their compressed air quality. That means residual oil measurement, how much oil is in the compressed air, how many particles are in the compressed air, and what is the moisture in the compressed air. And further on, we also offer the leak detection and leakage measurement. And on the right side, you can see that we also have the accessories, for example, like software solutions, current measurement, pressure measurement, temperature measurement, and electrical energy measurement. What kind of applications can be done with our instruments? So what we can see here is more or less a small factory, but it looks the same for the big factory. On the left side you have the compressor room. So in the compressor room we can, for example, do the efficiency measurement of the compressors. With our flow meters and with our electrical measurement we can prove is the compressor working like he should, or is it working ineffective and only needs a lot of energy but only a few air is coming out. Next step, we have the dew point monitoring and quality measurement. After the dryer, usually you have compressed air drying systems. Then we can also measure the consumption and flow of the demand profile, how much is needed in the factory. And last but not least, we have the leakage management. And the first thing we want to talk about is the cost of compressed air. Usually in the industry, a lot of people are not aware that the compressed air is very expensive. And due to the fact that the electrical energy costs were rising very much in the past years, especially in Germany, we have the problem that the electricity was rising tremendous since our government decided to shut down all the coal-fired plants and all the nuclear power plants. Energy is becoming more and more expensive, but it's the same situation all over the world. And if you look at the energy costs, you will find out that 73% of your compressed air costs are corresponding to the electrical energy. And only 20% of the costs are, let's say, the investment in your compressors. And only 7% of the costs are, let's say, the maintenance of the compressed air system. But the big thing of the compressed air is the electrical energy cost. And nearly every company needs these has compressed air. Whatever they produce, compressed air is needed for every production site. And if you are aware that 73% of your compressed air costs are energy costs, it helps you also, or it will help you to find out to save the money, to reduce your energy costs and to save money and be more competitive. So we have made a little example or a little calculation. If you have a small company, for example, with 150 people working there, and they have a compressor capacity of 60 meters cubed per minute or 960 meters cubed per hour, this is approximately a compressor with 100 kilowatt. So in 100 kilowatt, let's say they only work with 80% capacity, we can calculate with 80 kilowatt. But if they have a 3-shift system working 24 hours a day, you will come to the conclusion that this very small company already has a compressed air cost of 105,000 euros per year. So, and about 20 to 30% of this compressed air will be will feed the leakages. So all the compressed air systems are not tight, they have a lot of leakages, so the leakage rate is usually 20 to 30%. And this means even for a small factory, it's about 26,000 euro, which could be saved if you take care about the leakage. So what we can say is that compressed air, it's only air, but it's a very, very, very expensive air. And not only compressed air, all the other things you generate from compressed air on site, for example, with a nitrogen generator, you can have nitrogen, or with an oxygen generator, you can make oxygen on site. And all the other gases, they are even more expensive than compressed air. So it's always worth to find and be more effective. So, if you want to measure where your compressed air is going to, you have different locations in your factory. On the left side, you can see the generation of the compressed air, the compressor room. There you can measure in the main pipe, you can measure the total consumption, you can measure the costs of your compressed air in meters cubed. And of course, you can also see the total leakage rate. So if factory is stopped during the weekend, you can see on the flow meter how much is the leakage rate in your company. In the middle of the slide, you can see the buildings of the factory, and if you have one flow meter in front of each department, you are able to say in which department do we need how many compressed air. And of course, you can determine and allocate the costs to your departments. And on the right side, we can see, let's say, the process or the machine where the compressed air is needed. And if you install a flow meter in front of the process, you can allocate the costs to your products which you produce. So let's say if you produce, for example, cement, you can say per 1 ton cement we need compressed air for 10 euros. Or if you produce screws, per 1,000 screws, we need compressed air for 100 euros, and so on and so on. So for the flow measurement, we have different devices. We have the insertion sensors, you can see on the left side, and we have the inline sensors, which can be used in a distribution network. And we have the compact sensors, which could be used in front of a machine. And we have the vortex sensors for special applications, like flow measurement in very hot air and very special applications. Then the sensor selection. So we have the sensor family VA500, 520, 525, and 521. They are usually used for, let's say, easy flow monitoring inside the factory, inside departments, typically for leakage rate analysis, and they are for indoor use only. So they are usually used for air, nitrogen, argon, and so on. And then we have the family with industrial housing. They are called VA550, 570. They are available with ATEX approval. So if you have ATEX area in your chemical plant or pharmaceutical plant, you should use those sensors. They could be used for outdoor installation, IP67 rating. They have a robust metal housing. Then we have VD500. VD500 is designed for free air delivery of the compressor. So if you want to check the compressor, you can use VD500 directly at the compressor outlet to check the performance of the compressor. And the VU570 and VX570 are for high temperature applications up to 350 bar, liquid, steam, and so on. The most common sensors are the thermal mass flow sensors. Why are they so successful, or why do we use the thermal mass flow meters? The thermal mass flow meters, they have a direct measurement of the mass flow, let's say mass flow in kilogram per hour. Then you can calculate back to standardized volume flows, normal meters cubed per hour. And then they have the advantage that you have only one sensor. You can measure both. You can measure the small leakage rate during the weekend, but you can also measure the high flow rate during manufacturing during the week. So it's ideal for compressed air, technical gases, mixed gases, and so on. How does it work? So the working principle is as follows. There are two resistors, like PT100, like a temperature measurement. The blue one is the cold one, is measuring the air temperature, and the red one is heated approximately 8 degrees higher than the blue one. And so the flow will cool down the red one, and the electronic internally is increasing the heat to keep it at constant over temperature. And the more energy the electronic needs to feed the PT100 chamber, the higher is the volume flow through your pipe. That's how it works. In comparison to this, we also have a second type of sensor. The second type of sensor is a differential pressure measuring principle based on the so-called pitot tube principle. And this is very robust against condensation at high temperatures, so it could be used for the so-called free air delivery measurement of the compressor, FAD measurement. And it's a measurement for the, if you have very fast processes and you need a very quick response time. How does it work? So the sensor has internally a precise differential pressure sensor, which measures the dynamic pressure, which is, let's say, the difference between the total pressure and the static pressure. And the dynamic pressure is according to the air velocity inside the pipe. So it's a quite common way to measure the volume flow. Next measuring principle we offer is the vortex principle. Vortex are usually used up to 350 degrees, could be used in gases, liquids or steam, and they also could be used when we have to measure the unknown composition and changing gas composition. So it's a big advantage of the vortex flow meter. How does it work? We have an obstacle, the so-called vortex shadow bar, and after the shadow bar we have the vortexes, and the sensor element is detecting the frequency of the vortexes, and this frequency can be measured, and the frequency of the vortexes is more or less, let's say, the same value like the airspeed in the pipe, and if we know the pipe diameter, we can also calculate the volume flow. All the flow meters we offer have very modern interfaces. So, of course, they still have the old analog output 420 milliamp. 420 milliamp is very common in industry. 420 milliamp is still available. But nowadays, all the people want to connect the sensors to their PLC system or to their computer network. And therefore, all the sensors are available with the Modbus RTU, RS485 interface. Some of them also with a Modbus TCP, Power over Ethernet interface. Some of them, or all of them, with the MBus interface. MBus is a so-called metering bus, especially for energy monitoring system. That means you can connect all the sensors to the company's network. They get their own IP address, and all the values can be transmitted to a server or to a computer software. We also offer a so-called network software. So this is an online monitoring software, which is a server-client installation. That means you can mount all the flow sensors in your network, and that's number 2 on the screen. You can see there is a server, and the server is let's say, saving all the data simultaneously, and then all the users who are interested in looking at the values, they can connect with the software to the server, and then they can check what happened during the night or during last week. So we have an alarming function, sending out emails, we have a reporting function, the software will automatically send a report, who needs how much compressed air per week, per month, per year, and so on. And the big advantage with this software, you have no running costs. You don't have to pay a monthly fee. You buy the software once, and then you can use it over the years. So this software also offers you to have your own created dashboards. Dashboard means that you can set up your compressor station, how it looks in your company. All the design can be made by yourself. And then you can read the values on the compressor, on the dryer, on the vessel, and in the flow sensor, for example. And of course, you can do the same setup if you want to have a quality measurement, where you measure the particles or the residual oil measurement. Or you can have another dashboard where you can have a photo of your factory and all the values from the software coming to this one screen. So these dashboards you can absolutely create freely. Okay, so let's come to the next topic. Next topic is the dew point monitoring and air quality measurement according to ISO 8573-1. And one of these factors which should be measured is the so-called dew point. So compressed air should be dry. If you have compressed air which is wet, you will get a lot of problems. And therefore, there is an ISO standard, international standard, which has certain limits, and the limits show exactly, for example, if you have class 1, your dew point should be below -70. If you have class 2, dew point should be below -40, and so on. Okay. Okay, you can read it. I changed because I cannot read it. Sorry. Same language, it's a little bit a problem for me. So, why to monitor the pressure dew point? Monitoring the pressure dew point helps you to avoid damages to your machines and equipment. So, nearly every industry needs compressed air, and if you have compressed air, condensate in your compressed air, you will have a lot of problems. You will have a reduced lifespan of your pneumatic elements, of your valves. You will have increased failure of your machines. You will have corrosion inside the pipes, and of course, it's also affecting your product quality. You could have unwanted discoloration. You could have clumpy and sticky powdery goods. For example, if you have cement factories and the cement is forwarded with compressed air, the compressed air should be very, very dry. Otherwise, the cement is already reacting in the pipes, and then at the end, everything is blocked. So, product quality and process reliability are very, very important for the dew point monitoring. We also offer different, let's say, product ranges. We have the FA510 dew point sensor with an ATEX approval. If you have ATEX areas, we have FA500 with integrated display. We have FA550 dew point sensor with a very robust housing for the heavy duty industry, cement, steel factories, for example. And we also have the handheld instruments, DP500, which can be used everywhere and are portable. Of course, the dew point sensors could also be connected to a SCADA system or to a building management system with displays, either with DS52 display or with DS500, which is a kind of data logger. Then we also offer the particle measurement. So this is a very critical if you're in the pharmaceutical industry, if you're in the chemical industry, in the food industry, or in the semiconductor industry. If you're in one of these industries, you should avoid to have particles in your compressed air, and in this case you have to measure the particles. And particle counter which we offer is a cooperation product with one of the manufacturers who is manufacturing particle counters for clean rooms, and we have adapted the particle counter for the compressed air system. So we are able to provide a solution to measure particles down to 0.1 micron in your compressed air system. And of course, these particle counters, they are providing the values according to this ISO standard, ISO 8573-1. So last but not least, the last thing which is very important if you want to measure the quality of your compressed air is the so-called oil content. And the oil content is measured by our instrument, new instrument, OilCheck 500. This instrument is still under development, but we will launch it at the beginning of April. And if you're in the, for example, the same industries, pharmaceutical industry, food industry, also the breweries, Coca-Cola manufacturing, mineral water manufacturing, semiconductor manufacturing, it is important to have compressed air which is absolutely free of oil. And free of oil means that the compressed air has a much better oil content or improved oil content in comparison to our surrounding air. It's even better. And for this we have a new oil check. And the new oil check has an automatic auto calibration, which is called the force pressure variation. This helps us to have a long-term stable measurement. Then it is quite service friendly because we have no downtime. The sensor unit can be replaced by user on site. There is no need to send back the OilCheck 500 for recalibration. Then we have good process safety, so all functions are monitored internally. It is possible to have an on-site calibration when using test gas cylinders, and it also could be used for mobile measurement. Further on, it could not only be used in compressed air, it could also be used, for example, in nitrogen. It has a 40-20 milliamp output and a MOPAS output as a standard. It has a temperature compensation and humidity compensation to have stable measurements, and it could be used in normal compressed air, let's say from 3 to 9 bar, but we also have a version which could be used up to 300 bar. Okay, and the nice thing is the so-called pre-calibrated sensor unit. So the pre-calibrated sensor unit could be changed on-site by the user. So all competitors' instruments have to be sent back for recalibration. Our one could be changed on site, so the user can take out the old sensor, insert the new sensor, and go on measuring. And of course, the OilCheck will also be available as a mobile version in a case for all the people who have more than one compressor station. Last topic I want to talk about is the so-called leak detection. And the leak detection is a very important topic in compressed air. I already told you that compressed air is a very expensive medium. And with the leak detector compressed air, compressed air, LD500, you are able to find the leakages in your company very easily. So this tool will help you to save money if you use it usually, or some of your employees use it usually. Try to find the leakages of the compressed air, and if you then are able to close these leakages, you can save the money. And the nice thing is that the LD500 will show you the leakage rate in the display. So once you have found the leakage, it will show you the leak rate in liters per minute, and it will also show you the cost of the leak rate in Czech roads per year. So you can exactly decide this is a big one, we have to close the leakage immediately, it costs a lot of money, or this is a small leak, we can wait. So you can find the smallest leakages, it has an internal camera, you can photograph it, and then you can create a report. There is also a software available, and with the software you can create a report, give the report to the people who are responsible for closing the leaks, and they can close the leaks. And then you can save the money. So the return on investment for such a device is between 6 and 12 months. Compressed air is so expensive, and the leak detector in comparison to the compressed air cost is so cheap that after 6 months or 12 months you have the return on investment. And then we have the acoustic trumpet, we have the gooseneck, we have the parabolic mirror, so we have some accessories which makes you the work with the leak detector easier. And last but not least, we also have improved the leak detector. So the latest version, you can also watch the latest version over there. I took the LD500 UltraCam with me. It's the so-called UltraCam, which has 30 microphones. And with the 30 microphones, we are able to create, let's say, a photo which shows the leakages in the graphic. So it works like a thermal imager. Probably all of you know the thermal imager, the infrared cameras. And with this device, you can pinpoint the leak, and then you can see in the display at this position there is the leak. So it makes the work for the person who is looking for the leaks much easier, and it also helps you to save the money and reduce your compressed air costs. So thank you very much for your attention. If you have any questions, we have a translator. Because I'm sorry I'm not able to